Hello, everyone. Welcome to your ticket to retake the topic 2 test. This is our review we have to have complete to retake the test. So I'm going to just go through and do a little reteaching. You can use this video however it will help you best. All right, number 1, describe how each function was translated from f of x equals x squared. So x squared is just our parent function. The vertex is at the origin. And we can translate these parabolas around. Anytime we see numbers added in, whether it's on the end or inside parentheses with the x, these are going to be horizontal and vertical shifting. So for number 1, we have our x squared, and then we're adding a 4 on the end. Any numbers that we're adding or subtracting the end will be a vertical translation. So this one means we're going to go up, so it's positive 4, so up 4 units. Number 2, f of x equals, so here's our x. It is being squared, which makes it a quadratic, so it's still our parabola shape. But now we are subtracting 3 from the x. So inside the parentheses, we have an x minus 3. This is going to be a horizontal shift. Your x's are horizontal in a coordinate plane. And that minus 3, we're just going to remember it's the x is tricky. So when it says minus 3, we're going to go in the opposite direction. So we're going to go to the right 3 units. We do notice that there is not a number on the end, so there is no vertical shifting for that example. Number 3, f of x equals x plus 2 squared. So there's our x squared making a quadratic and a minus 1 on the end. So inside we can see an x plus 2. That's going to shift your x's, which is horizontal. When it says x plus 2, we're going to go in the negative direction because of tricky x. So we're going to subtract 2. And then that minus 1 on the end tells us that we are going to go down 1 unit. So that's how each of those functions gets translated from the parent function x squared. Number 4, identify the vertex, axis of symmetry, maximum minimum value, and the domain and the range for each function. And wow, there's not a lot of space here. So let's see what we can fit in. So the vertex, if it was just our x squared function, the vertex would be at the origin, but we have translated this. So these are our shifting numbers. So x minus 2 means that our function went to the right 2, and that plus 3 on the end, it went up 3. So if you can picture going from the vertex to the right 2 and up 3, our vertex is now at the ordered pair, or at the point 2, 3. The axis of symmetry goes right through the vertex, and it's always going to be x equals, it's a vertical line. And the vertical line that goes through this vertex will have the same x value as that coordinate. So x equals 2 is our axis of symmetry. Maximum or minimum, so our a value is found in front of our parentheses. Right here, our a value is a positive 1. Because that's positive, that means that this parabola is opening up, which gives us a minimum value. So the minimum value is how low does your graph get? Well, the vertex is the lowest point on this parabola. And because we're talking how high or how low, that is a y value. So the minimum value is a positive 3. It's going to be that 3 from our vertex. Domain. So domain for all quadratic functions is all real numbers. In interval notation, we would say it's negative infinity to positive infinity with those parentheses. So the reason why our domain is all real numbers, domain is your input. Numbers we're allowed to plug in for x and like still be okay mathematically, still be in our real number system. We can plug in any number for x, subtract 2, and then square it. We don't get stuck mathematically on anything. So that means x can be all of the real numbers. So our domain is from negative infinity to positive infinity. And last, we have range. Now, the range is going to change depending on where your vertex is. In this little side drawing I have here, where our vertex went to the right 2 and up 3, right here, we can see that our range, our y values, start at our vertex and then It's everything bigger than that. We don't have any values below that vertex. So that's going to be a 3. That's the y value of our vertex. So our range, the smallest y value, the lowest that that graph gets is 3. And it continues all the way to positive infinity. So we have a parenthesis with our infinities, but then because the 3 is part of the vertex, that is included with the range, so that will get a bracket. All right, look at that, we fit it all in. Okay, so number 5, we're just going to run through a little bit faster because I did more explaining on that one. Our vertex is going to be at, switch colors, here we go. Vertex is going to be at a -3, +2. The axis of symmetry is x equals that -3 from our vertex. Remember, axis of symmetry is the vertical line that goes through this point, cuts your parabola in half. What else do we need? Maximum or minimum. So our a value is negative, which means that this graph is opening down. So now we have a maximum because we have a highest point. So the maximum is equal to how high did that graph get? And if your vertex is at -3, +2, that 2 value, the y, tells you how high your graph got. Domain for all quadratics is all real numbers, so -infinity to infinity. And then our range. Now our range is going to go, if you notice, the biggest number in our range is a 2, because that's how high your graph gets. And then all the numbers smaller than that. So when we do interval notation, we always start with the smallest number. In this case, that's a -infinity. This function is going to go all the way down and, continue forever into all those negative numbers. And then the highest that our graph gets is a +2. So parentheses with infinity, and the 2 is part of our range, so it gets a bracket. All right, last one for this section. Our vertex, we can see that x plus 4, so we went to the left 4 and down 1. So left 4, -4, down 1, -1. Axis of symmetry is x equals, and it's going to go through the vertex, so x will equal a -4, that vertical line. This this quadratic function has a 1 for your a value, which is positive, so it is opening up. That just gives us a nice visual to see that we have a minimum, not a maximum. So our minimum value, how low does our graph get? That's going to be that y coordinate of your vertex. Your vertex is the lowest point, and how low does it get? All the way down to a -1. Domain, hopefully we're good with domain now. It's all real numbers or -infinity to infinity with parentheses. And then our range is going to be equal to range in interval notation. The smallest value is on the left, the largest value is on the right. It's the interval from here to here. So the ranges are y values. So the smallest value is right here. How low did our graph get? Our graph got all the way down to a -1. So that's our minimum part of our range. Oops, that's not a -1. -1. And then how high is it going? Well, it's just going to continue forever to a positive infinity. Parentheses with infinity, bracket with the -1, because -1 is part of the range. All right, number 7, write the equation of each parabola in vertex form. So if we ever are unsure what this vertex form should look like, you can scan through the test and try to find an example where you can say, oh yes, that's vertex form. So these are all vertex form. What you'll notice is you have an a value out front. You have your x plus or minus a number, the squares out parentheses, and then a plus or minus number on the end. So we can go ahead and write vertex form because we are given the vertex on this. What we don't know is the a value. So y equals, we don't know our a value, but we know it's going to be x minus 3 because of tricky x squared, and then minus 2. All I did was I took the vertex, positive 3, so minus 3 right here, and then negative 2, minus 2 on the end. So it's that easy. Well, there's our vertex form. The only thing we don't have is our a value, and that's why they give us a point on your parabola. I want you to think of this as like a helper point. It has an x and a y, so we can plug in the x and the y. Any point on this parabola will work in this equation. So I'm just going to plug in a 3 for the y. We don't know our a, but I'm going to plug in a 2 for the x. We're just going to solve. This part right here, we're going to get this simplified down to a single number first. So 2 minus 3 is negative 1, and negative 1 squared is a positive 1. So we have a positive 1 times a, and then the minus 2 I just carried down. Then we'll just go ahead and add 2, solving for a. So 5 is equal to 1a, which is the same thing as a. So a is equal to 5. So our equation, or our function, y equals, now we know a is a 5, and then x minus 3 squared minus 2. There's our vertex form. All right, number 8, same idea. We know our vertex. What we don't know is the a value. So y equals, here's a, what we're missing, and then x plus 4, because of tricky x, squared. Don't forget that squared. That's really easy to forget, and it totally changes your answer if we don't have that in. What we want to remember are all parabolas or quadratic functions. The reason that they form a parabola, or we call them quadratics, is because of that squared. So that's a key piece right there. And then minus 24 on the end. Now to get our a value, we're going to plug in a helper point. So they gave us this helper point that has an x and a y. I'm going to plug in negative 25 for y equals a times our x is negative 5 plus 4 squared minus 24. First thing we'll want to do is get this simplified into a single number. Negative 5 plus 4 is negative 1. Oh, we got a negative 1 again. Negative 1 squared is positive 1. So we're going to have 1 times a minus 24. I'm going to carry down minus 25. And then we'll just solve for a. Add 24 to both sides. And then we're getting a is equal to negative 1. So our final answer is going to be y equals negative 1 times x plus 4 squared minus 24. This negative 1 right here, if you just wrote as a negative instead of a negative 1, it would be the same thing. All right, last problem for this first page. Find the vertex, axis of symmetry, and y-intercept of the function. Then sketch the graph. Well, I didn't really provide you with a graph, so maybe we could just draw a sketch. This is vertex form up here. Now we're switching to standard form. Standard form is, let me just write the form out just as a friendly reminder. Y equals ax squared plus bx plus c. So in this case, the a, b, and c are these coefficients. The number in front of the x squared, so picture a 1 being there, maybe I'll even write it in. A is equal to 1, b is equal to negative 8, and c is that positive 19. So to find the vertex in standard form, we have a little formula to follow. It's x equals negative b over 2a. So here's my negative. I'm going to go to our b value, which we said was a negative 8, or over 2 times a is a 1. So we often see that, a negative negative. This negative, the first one, is built into our formula, and then I plugged in a negative value, so that's going to turn into a positive 8 over 2, which gives us 4. So our vertex, I know, has a 4 for the x value. Now the y value, we're just going to plug a 4 in for the x's and simplify to see what the y is. So y equals 4 squared minus 8 times 4 plus 19. And that gives us a positive 3. So our vertex, we know the y coordinate is 3. So our vertex is at 4, 3. Axis of symmetry is going to be that equation x equals, and then it's going through the vertex, so x will equal this 4 right there. And then the y-intercept, in standard form, the y-intercept is your c value every single time. So in this case, that's a 19. So your y-intercept is the ordered pair 0, 19. Now for the sketch, I suppose, let's just throw in a sketch, right? Why not? Let's see, so 4, 3. If I go over 4 and up 3, that's where our vertex will be. And then because our A value is 1, this would have a 1, 3, 5 graphing pattern. Your A value is positive, so it is going to open up. So there's just a little sketch of our parabola.